Alright, here we go. Section 10.4. This is my fourth video tonight, so bear with me, and I will do my very best to get through it as quickly and as correctly, efficiently as possible. Alright, once again in 10.4, as the saga of the circle continues, we learn more vocab. We've got the inscribed angles and intercepted arcs. An inscribed angle. For it to be an inscribed angle, I must have the vertex must be on the edge of the circle. Must be on a circle. In the sides of the angle must be chords. So these blue segments here are chords in the circle. Okay? So this angle right here, if I kind of draw an arrow in here, is an inscribed angle. Okay? An inscribed angle. This arc right here from these 2 points, endpoints on an inscribed angle, this is called the intercepted arc. The intercepted arc. Okay, intercepted arc. Two things, we've got intercepted arc in orange, inscribed angle in blue. Let's learn about these things. Let's move over here to 10.7, measure of an inscribed angle. Well, so, once again, let me give you some information here. This angle we'll say is 33 degrees. And this theorem says that the measure of angle ABC equals 1/2 of the measure of AB, arc AB. Okay. Measure of angle ABC is half of the arc. Okay. So here's my arc AC, and that's half of it. So in this example, if this is 33 degrees, angle B is 30, then this arc in blue must be 66 degrees. Okay. This is much different than a central angle. Now I don't necessarily want you to write this down. This is for explanation purposes only. But remember, this thing in blue was a central angle. So if we said that this angle was, don't write this down please, if we said this angle was 55 degrees or 65 degrees, then this arc out here was also 65 degrees. I want you to see the difference. We've got going from the center, the central angle here. Those are the same. Over here, we have an inscribed angle from one side to the other side. This arc out here in blue is twice the angle here on the inside. Okay? So once again, please don't write this stuff down, but that's just to show you that there's a difference between an inscribed angle and a central angle. Okay, moving on. Let's do some examples here. If I want to find the measure of angle ST, arc ST, I want to find this arc here. Well, here's what I know to help me figure it out. I know that I can find this arc out here, TU, first, because I know that if this angle on the inside, the inscribed angle is 61, then this must be twice that. Okay, so the measure of arc TU equals 2 times 61. Times 61, which is just 122. 122 degrees. Okay, so that means that this arc is 122. I know that this segment, SU, is a diameter. So if I wanted to go all the way around, the whole thing must be 180. Right, so if I went all the way around from U, all the way around to S, that whole thing would be 180. So the measure of ST equals 180 minus 122, which just gives me 58. Just gives me 58 degrees. Okay, so that's it for that one. Okay, we've got to use a number of reasoning skills there. The most important being the inscribed angle. Sorry, that's a T. Gosh darn it. Okay, the inscribed angle theorem. Okay, let's move on to the next example. In this one, I want to find VST, arc VST. So let's identify what we're looking for first. V to S to T. Alright, so that's what I'm looking for. This one, I'm going to have to use even some more kind of further reasoning, alright? Let's see if we can't find VU, okay? My whole goal here in this example is to find all the arcs. To find all the arcs to help me figure out what VT is. I want to find all the minor arcs in the picture. I already know that TU is 135. I'm not worried about that one. Let's find UV. Well, if this is 51, this angle out here must be 102 degrees. It must be 2 times 51. So that's 102. Okay? So that means that I know VU. Got that down. I know TU. I know SV is 39. The only thing I'm missing is ST. Let's figure out ST real quick. The measure of ST equals 360 minus, I'm going to run out of room, 135. Gosh darn it. Minus 102, minus 39, okay? And when all shakes out there, because I'm taking the whole thing, I'm subtracting everything out. When all shakes out, I'm going to have the measure of ST is going to be 84 degrees, okay? So I go over here, I know that this is 84. That means that finding the measure of VST is pretty simple. I'm going to take 84, add it to 39, and when I add those two things, I'll get VST is 123 degrees. 123 degrees. Okay? And that's it for that example. Let's move on to Theorem 10.8. Theorem 10.8 says the following. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. Okay, so if I take, and this is very important, if you have highlighters, if you have a marker, if you have colored pencils, anything like that, it's going to be very helpful to see this actually happen. DA and DC intersect, intercept this arc here, DC, and I'm going to draw this one in blue. Alright, and what this says is, this theorem says this: if angle DAC and DAC and DBC intercept DC, then I know this, the following, that angle DAC is congruent to angle DBC. Okay, so then I know this thing in purple here, that these two angles must be congruent. I think you could kind of probably reason your way through that, but it should be explicitly stated that those two angles are congruent because they intercept this same arc. Okay, so that's why I say colored pencils or a marker are going to be really helpful for you to kind of see that happening there. Okay, so for instance, in this example, if I take the measure of angle K, I'm going to find the measure of angle K, and I know that both JKM and MLJ intersect this green arc here, the same arc, then these angles must be congruent. That means that the measure of angle K must just be 28 degrees because they intersect the same arc JM. Okay, and that's it. That's the reasoning that you got to use for 10.8. Let's move on to inscribed polygons. Okay, so that'll be next, and let me see if I can bring that up for you real quick. Maybe not. You have to tell me and let me know if you think that this is a better way to do one long video or to do several short videos. I don't care, but it's kind of whatever you guys think. So let me know tomorrow in class if you would prefer one long video or several short videos. One problem with the long videos, you have to sometimes wait for me to change the screens. But anyway, okay, here we go. Inscribed polygons. An inscribed polygon means that all the vertices are on the circle. Okay, that's it. If I've got a polygon, all the vertices are on the circle, and I'm good. Okay. So for instance, if I've got polygon A, B, C, D going on right here, it's a nice polygon, A, B, C, D. A, B, C, D is inscribed. Is an inscribed polygon. Okay, is an inscribed polygon. That's it. ABC is inscribed. That's all it means. All the vertices on the circle. Cool. Circumscribed circle is that circle that contains all the vertices. Okay, so if I change colors in orange here, these circles are called circumscribed circles. Circumscribed. Long word, circles. Circumscribed circles, okay? Right here and right here. Okay, let's move on to 10.9. 10.9 says this. Let's say I've got a right angle down here at ABC. Okay, so let's say measure of angle ABC equals 90. Okay? Equals 90 degrees. That is true if and only if AC is the diameter of the circle. AC is a diameter of the circle. So, for this example, down here, so that's theorem 10.9, let's move on to the example. A quadrilateral can only be inscribed in a circle if and only if its opposite angles are supplementary. So we're knocking down these theorems as fast as I can here. A quadrilateral can only be inscribed as blah, 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 blah. So this says this. A, B, C, D can only lie on the circle That's a symbol for circle. Lie on the circle if the following. Okay? If the measure of angle DAB, you know what? Let's forget that. Let's label these angles. This is angle 1, 2, 3, and 4. How about that? That's going to be easier. If the measure of angle 1 plus the measure of angle 4 equals the measure of angle 4 plus the measure of angle 2. And one mistake, sorry guys, one mistake here is that this should be the measure of angle 3. Okay, opposite angles are supplementary. Okay, and if those two things are equal and they equal 180, that's maybe the most important part, is they have to equal 180. Okay, so those angles, opposite angles, are supplementary. They add up to 180. So in my example over here, I know that P plus R must be 180. They're opposite angles. Must add up to 180. So 63 plus 3x equals 180. Okay. 63 plus 3x equals 180. You'll get down to x equals 39. Over here, I've got 65 and 4y minus 1. 65 plus 4y minus 1, that must equal 180 also. Okay, and then I get down to y equals 29. Okay, So those two examples there. And then I think, let me see here, I think that I want you to do BC number 9. Let's see, find BC. Yeah, you guys should do that one on your own. That'd be a good one. Do 9 on your own, and then also do that last example there to the right on your own. Okay, so these ones should be on your own. Try them, figure them out, and see what you get. We'll look them over in class tomorrow. Bring any questions you have, and then we'll also work on the homework in class tomorrow. See you later.